Congruent and similar polygons. Congruent means every single angle matches up to another one and every single side. And yesterday we talked about similar triangles are the same shape, but they're different sizes. So they're both going to be triangles or they're both going to be rectangles, but they're going to have a scale factor. So we're going to expand on similar polygons even further. So we talk about if two polygons are similar, their corresponding angles are congruent, meaning every angle in the left shape matches an angle in the right shape identically. Then after you've determined that, they also have corresponding sides that are proportional. And I'm going to remind you, proportional means they have the same scale factor. That's what we did yesterday when we set up 6/2 and 3/1, and we said, yep, they're proportional because they have the same scale factor. Okay, so polygons have the same shape and are called similar polygons. In this is, I'm going to shortcut what they say here. This symbol means congruent. An equal sign with a tilde means congruent, which means that they are identical size. Today, you're going to see just the tilde, which means similar. Similar means they have the same angles and the sides use a scale factor. You're going to need to remember the difference between congruent symbol and similar symbol because it will matter on your assessment. All right. We can go through their examples. I think they're choppy and confusing and we skip over a lot of it. So let's just go to guided practice. We're going to do 5 problems together. So the very first thing they're going to ask us to do is determine whether each pair of polygons is similar and explain. So the first thing you have to check is, can I match every angle from the left shape to an angle in the right shape and guarantee that they're the same size? So on number 1, can we match an angle from the left triangle to the right triangle? Which one? Can you guarantee me an angle in the left triangle is equal to an angle in the right triangle? Why, Parker? Yeah, the 90-degree mark guarantees me that those are both 90 degrees. They are equal. Now, can you guarantee me this angle is equal to another angle in the right triangle? And right, I mean like direction right. No. Because there are not markings, you can't go like, I think it looks good. It doesn't work. It has to tell you that they're equal. So we don't have to go any further. These are not similar because the angles are not congruent. If your angles don't match up, you do not have to go any further. You do not have to go any further. So number 2, can we match an angle from the left quadrilateral to the right quadrilateral? This is where your swoops come in from the other day, right? This one swoop, I can match to this one swoop. This 2 swoops, I can match to 2 swoops. 3 to 3, 4 to 4. Does every angle on the left quadrilateral match an angle on the right quadrilateral? Yes. So now we move into the next part, which says our sides are proportional, aka just like yesterday, we have to see if they have the same scale factor. So my question for you, 18 from this quadrilateral matches up with what side on the other quadrilateral? 13.5. Very good. 10 on the left matches 7.5 on the right. 8 on the left matches 6 on the right. And the other 8 on the left matches 6 on the right. Does everybody see how we got those matched up because of those swoops? Okay, now yesterday when you were comparing scale factors, I made you get a common denominator. This is nasty because we have decimals. So everybody grab your calculator and divide these out. Figure out what each of these end up being as a decimal. $18 divided by 13.5. 1.3 repeating. 10 divided by 7.5. 1.3 repeating. 8 divided by 6. How about the other 8 divided by 6? 1.3 repeating. So what did that just tell us? Not congruent, they are similar. Because all the scale factors are the same, these two polygons are similar. Get ready to write a paragraph. They told me this is like writing a paragraph. Yes, these are similar because the angles are congruent and the sides are proportional. Yes, these are similar because the angles are congruent and the sides are proportional. Not really a paragraph. They were being a bit dramatic this morning. Questions on whether or not, or how you determine if they are similar. Okay, and a lot of people said, but Ms. Hoff, this is just like we did yesterday. So why are we spending a whole nother day on this? We determined if they were similar yesterday. So we're going to expand on that, and here they're going to tell us, hey, these two triangles are similar. I'm telling you they're similar. Which means the angles from the left triangle are going to match the angles on the right triangle, and the sides are proportional. They match up with a scale factor. Now, looking at where your angles are, what transformation would you have to use to match these triangles up? A rotation. Because look, you have one swoop here. Do you see that? Your one swoop has to be in the other corner. If you reflected it, it's going to stay up top. So we would have to rotate it to get it to match up. Now, I'm not going to ask you or require you to write those transformations down, but it's something to talk about to make sure you're lining things up correctly. Okay, so we're going to do the same thing, and I encourage you to use shapes like I'm going to, because I know not a lot of you have highlighters. Okay, so what side on the right triangle would that 6 match up with? 3. Put a square around both of those. What side would 9 match up with? Y, because we have to rotate. And which side would X match up with? 6. I strongly encourage you to use different shapes like this to remind yourself what's matching up with what. Now, 2 of those sides have the same shape and they're both numbers. What are they? No. 6 and 3. Everybody follow me? 6 on this one as a square and 3 on this one. They match up and they're both numbers. So we're going to write down 6 over 3, just like we were figuring out a scale factor. We are not going to actually divide that. We are going to leave it alone. Bless you. Now, we are going to find X. Is X in the same triangle as the 6 or the 3? Is X in the same triangle as the 6 or the 3? The 6. So it needs to be in the same location in the fraction as the 6. The 6 is in the numerator, so X goes in the numerator. What other side matches up with X? 6. Is that what you were going to answer for me? Question. Correct. And actually, that was my very next sentence I'm going to tell you. This 6 and X came from the left triangle. They need to be in the same part of the fraction. Now, it could be the denominator, it could be the numerator, as long as they're the same, because 3 and 6 are both from this triangle. Now, the nice part about this, we're going to do the butterfly and cross multiply. Show work. 6 times 6 equals 3 times x. 6 times 6 is 36. 3 times x is 3x. Then I divide by 3. X equals 12. That missing side length would be 12. Okay. Go to number 4. I want you to put shapes around the sides that match up. Match up those numbers. Put triangles along from the left that match the right. Put a circle from the left that matches the right. Match up the 3 sides on the left with 3 sides on the right. What matches up with 5? 4. What matches up with x? 4.8. What matches up with 10? 8. Just like Davion did in the last one, pick a number from the left that matches a number on the right. 10 matches to 8. Okay. Do you have to do 10 and 8? You could do 8 and 10. What else could you do? 5 and 4, or you could even write it the other way of 4 and 5, right? It doesn't technically matter. What matters is how the other side is written. So now I'm going to find x. Should x go in the numerator, the denominator, and why? Why? Very good. X is in the same triangle as 10. 10 is in the numerator, so x needs to go in the numerator. What matches up with x? 4.8. On your own, cross multiply. See what you get for x. Ten times 4.8, 48. 8 times x, 8x. Then I should divide by 8. X equals 6. X equals 6. Go to the top. Put the shapes around the sides that match each other. Go match up those sides. What numbers go with what numbers? Okay. 13 matches up with nothing. It's a blank space there, right? 10 matches up with 15. 12 matches up with M. And then technically 24 would match up here, but it doesn't have anything. So really 13 and 24 are useless to us, yes? Okay? On your own, don't say it out loud. Write down the fraction comparing a number from the left to a number from the right, or you can go right to left, whatever. You could have written what? 10 over 15 or 15 over 10. It doesn't matter. What matters is the other side. So no matter how you wrote it, now write the other side, placing m in the correct location, whether it's in the numerator or the denominator. If I say 10 over 15, the other side should say 12 over m. If I say 15 over 10, the other side should say m over 12. Cross multiply. You can do it either way. I'm just showing you both. You can do it either way. I'm guessing most of you wrote 10 over m, or 10 over 15. $15 times 12, 180. Divide by 10, m is 18. You may wind up with a decimal today, and Miss Hoff's okay. If it's a crazy long decimal, you know you've done something wrong. Question? Like right here? No. If you go straight to this step, I'm okay with that. Is that what you mean? Yeah, if you erase that middle, that 10 times m and 15 times 12, I'm okay. On your homework, on problems 3 and 4, it says determine the transformations. You do not have to write that out. I'm just really asking you to find the missing side measure. All right, your homework. 1 through 4, 6, 9, 10, 13 through 18. As you're working, I will give you some spot check answers to make sure you're on the right track. What's my goal always on a Friday? No homework. Minimal to no homework, right? Okay? So please, please, please use your time wisely.